Just write these percentages over here. Yeah, the percentage of potassium is 54.93. The percentage of boron is 38.73. And the percentage for hydrogen is 6.34. Right? What is the next step that we do after this? Yes, we assume the percentage to be out of 100 grams. Now these are the values will still remain the same. I have to just convert them into grams. So mass in 100 grams. So your 54.93% becomes 54.93 grams. Your 38.73% becomes 38.73 grams. And your hydrogen, which is 6.34%, becomes 6.34 grams. Okay. The next thing is we'll be converting these values to number of moles. Okay. Let's try to again remember the formula for number of moles. It is N is equal to given mass upon molar mass, right? Perfect. So what is the mass for given mass for potassium? It is 54.93. Okay, and what is the molar mass? If you have a look at the periodic table, you would come to the conclusion that the molar mass of potassium is 39 grams. It's actually 39.093 to be very precise. So the number of moles that I got for potassium is 1.40. Similarly, I do the same thing with boron and hydrogen, and the values that I get is 3.5 and 6.34 respectively. Okay, what is the next thing that I do after finding the number of moles? Yes, you select the smallest value and divide all the values by this small one. So out of these values, the smallest is 1.40. You are now supposed to divide all these values with 1.40, including this value. Okay, so I divide 1.40 by 1.40, I get the answer as 1. Then I divide 3.5 by 1.40, I get the value as 2.55. And then I divide 6.34 by 1.40 and I get the answer as 4.5. Now potassium is a whole number, whereas in the case of boron and hydrogen, they are not whole numbers. To convert them into whole numbers, I need to multiply with a common number. I cannot multiply this with 2 and this with 4 or this with 3. That's not acceptable. If I multiply one value with a number, I have to multiply all the values with the same number. So since it is 2.5, it is always better to multiply it with 2. So I multiply all the values with 2.